Hello, good day, viewers. You are welcome to my YouTube. If you are just watching my video for the first time, can consider subscribing to our YouTube channel. Hit on the bell icon so you'll be notified anytime we upload the new content. So, in today's tutorial, we're going to be looking at the value of x. So here we are asked to solve for the value of x, that is x to power 6 equals 9 to power x. So therefore here, we are going to rewrite this equation in this format. Let's say we have x to power 6, okay, equals 9 to power x. So what I did is to rewrite the equation. So now from here, I can rewrite the power as having x to power 3, then into bracket, we have 2 here. So that is from the lot of indices that say when you have a to power m, okay, then we have n, right? So this implies that a is what m multiplied by n. So that is what we are trying to do here. So we have x to power 3, 3 times 2 will actually give us 6. So the same thing here, this 3, I can write it as 3 to power 2. Then I have this hex here. So now the same thing here, I want to write this 3 to power 2, okay, to power x again. So using this, that is when you have a m, okay, to power n, it can also be a, putting n inside and the m outside. So I'm going to interchange the powers here. So I have x to power 3, okay, to 2 equals, so this will be 3 to power x, then to power 2. So now as we can see, we see that we have their exponents now 2, 2. So which they are the same, okay? So now let's say you want to get rid of this power, that is 2, because they are the same. And when we get rid of these 2, it means we reduce the equation to a simpler form. So then from there we solve further. So now from here you can see that these 2 will actually cancel these 2, but I don't want to do it like that. So let's say we take the square root of both sides. Taking the square root of both sides like this, okay, you see that this square, we cancel this square root. So we have x to power 3 equals, then here we have what this one also cancel out this, we have 3 to power 3 to power x. So now from here, so this is the reduced form of this equation we have here. So now from here, let us introduce a natural log. So if you introduce natural log to the both sides of this equation here, so it's going to be having ln of what, x to power 3 equals ln of 3 to power x. So now from there, so we can see that whenever you have the power like this from the law of logarithm, that say log a to power b, so this is going to be, this b will come down multiplying log what, log a. So we are going to apply this here, okay. So now from there we have 3 ln x equals x ln 3. Are you following? So now the next thing we are going to do here is that we can try to do a separable variable, in the sense that you want to make the value or the variable x to be on one side and constant to be on one side. So what we are going to do here is that we're going to divide through by what, by 3x, okay, by 3x. So now from here you can see that 3, we cancel this 3 here, we are left with ln x over what, over x, right? Then x over x, then we have equals this x, we cancel this x here, I have ln 3 over what, over x. So now you can see this is very beautiful. So now from here, the next one we can do is that we can actually do the comparison, okay. So the comparison of the two sides, so which shows that, look at this place here, look at this place here. So since we have ln x here, okay, and we have ln 3 here, and here we have, sorry, is it ln, this one here is supposed to have 3, not x. So we can see we have x and we have 3 here. So definitely, because look at it, this x we cancel this x, we are going to be left with 3. So now this and this, so we can compare this and this. So therefore, comparing either the argument of this line here or here, this one that is the denominator and the denominator here, we can see they are the same thing. So therefore we can conclude that is by comparison, okay, we can conclude that x equals what? X equals 3, right? So now that is that. But we can also know, let's say from here, that we said ln x over x equals ln 3 over what? Over 3. From here we can continue from there by saying, okay, if you don't want to use comparison method as we did there, can we actually use another form? So we can use Lambert w function to get the value of x. Then we see that we're going to get the value of x to be 3. So now by Lambert w function, so that is, we have Lambert to be w a e a, it will give us what? It will give us a. Okay, so now from there, so what are we going to do? We are going to rewrite this as that. So now here I want you to remember that if you have e ln x, okay, this will actually give us x, because e and ln, they are what? They are inverse to each other. Okay, so now from there, so what we are going to do is that we're going to see that we are going to replace that here, bring that down. We have ln x over this place, we have x here, we can replace it to be e ln x, okay, then equals, so here that we have ln 3, so we can have ln 3 over e ln 3. Do you understand now? So we apply the same thing we apply for x here, we apply it here. Do you understand now? So from here we can rewrite this equation to be like ln e to power ln x e to power minus ln x equals ln 3 e to power minus ln 3. Okay, so now the next thing you are going to do here is that so here, now how did we get minus ln x here? If you remember from law of indices, when you have a to power minus 1 like this, is same thing as 1 over a. So that is the idea I used here for writing this e ln x that is down, that is the denominator. So now bringing it up here, definitely it will have this negative. So now from here you can see we have ln x, we have minus ln x. Now if you want to compare it with this, so the Lambert w function said if you must operate this on a function, so it's going to be a. Definitely what you have here must be something you have here, which is a. So now when you look at this, we see we have minus ln x here, and we have what? Ln. Okay, so definitely we need to multiply the both side by minus 1. Okay, minus 1 times ln x e minus ln x equals minus 1 times ln 3e ln 3. So now from there we can now see that if you multiply this, we can see that we are going to be having minus ln x e minus ln x equals, from here we have what we have also, minus ln 3 e minus ln 3. So now from there, the next thing we are going to do, we can see that we're now going to operate this. We take the Lambert function on this, minus ln x e ln x equals w minus ln 3, okay, e minus ln 3. Now from there, the next thing you do is that we can see that taking this one, we have minus ln x here, we have minus ln x here, so it shows that our solution here is going to be minus ln x equals, this one will be minus ln 3. So now this one we cancel this. Okay, now taking out this ln, so definitely you're going to have this argument to be s equals to 3. Do you understand now? So whenever you have that, so now that is the solution to the problem. If you find the class very interesting, please kindly share this class to your colleagues so they can also benefit from it. Thank you so much for watching. Bye bye.